Today we're going to go over rate of change. And to go over the topic, I have a handout I made, and we're going to start by looking at the definition. Rate of change is the rate that describes how one quantity changes in relation to another quantity. If x is the independent variable, input, and y is the dependent variable, output, then your rate of change is equal to the change in your y variable divided by the change in your x variable. Another way to calculate rate of change between 2 points, we'll call them a comma b and c comma d, and we have a formula here where to find the change in y, which I denote as delta y, you subtract your y values or take the difference, and to find the change in your x, you take the difference of your x values in your coordinates. Rate of change can be a positive or negative value. A positive rate of change means that the y value increases during the interval. If there is no change in the y value, we have zero rate of change. Here's a quick example to illustrate. Calculate the rate of change between the points 5, -3 and 1, 5. Okay, so to do that, I'm going to go ahead and write rate of change. And we're going to go ahead and label our points here. We'll just call this the A and the B coordinate, and this will be the C and the D coordinate. So the way that I use the formula is it's the y coordinates subtracted on top, so D minus B. So that'll be 5 and -3. And then you subtract them over the difference of C minus A, which would be 1 minus 5. So on the top there, 5 minus a -3 gives us 5 plus 3. And on the bottom, 1 minus 5 is -4. So we have 8 over -4, which is -2. So the rate of change between the 2 points would be -2. Moving on, we have a table that says to find the rate of change on the interval 2, 6. And the table has some x values and some y values. Well, since we're finding the rate of change over the interval 2, 6, we want to go from this set of values to this set of values. So we could do the same thing we did before. I can label my first set of values A and B, so A comma B. Second set of values as C and D. And we'll just take the difference. So this would be a difference over difference. And so we'll have 240 minus 80 on top. And on the bottom, we'll have 6 minus 2. And that would give me 160 over 4, which is 40. And the units would be miles per hour. So the average speed, right, the average rate of change would be 40 miles per hour. Use the table to the right to answer the following. Which runner has the fastest average speed, rate of change, for the first 9 seconds? So since we're only talking about the first 9 seconds, that would be this information here. So if you notice, both runners have the same distance traveled. So if we find the average rate of change for one runner, we find the average rate of change for the other. So just to show the calculation, our rate of change for either runner would be the distance traveled minus the original distance, right? So this would be 120 and 0, subtract them, over the interval time, 9 seconds, minus 0. So this would be 120 over 9. And that does reduce to 40 over 3. And that's how fast they were able to run. It doesn't give a unit, but that is the average rate of change. 40, whatever the distance unit is, over every 3 seconds. And I could turn that into a decimal, but I'm just going to leave it as is. Which runner has a faster average speed, rate of change, from 9 to 20 seconds? So to look at this interval, we're going to look at these values from 9 to 20. So for runner A, we are going to subtract the distances traveled over that interval. So 168 is the y value at the end of the interval, and 120 is the beginning of the interval, over, and subtract. And on the bottom, we subtract the time interval, which is 20 seconds minus 9 seconds. So on the top here, this would be 48. And on the bottom, that's 11. So 48 over 11 would be the rate of change. And then we have to calculate runner B, which would be 213 minus 120 over the same 20 minus 9. And this would give us 93 over 11, which, since they're both over the same denominator, it's easy to compare. 93 over 11 is greater than 48 over 11. So runner B has the faster average speed in that interval. Okay, now we're going to look at which runner has a faster average speed, rate of change from 9 to 31 seconds. So runner A, we'll just say A. So this is from 9 to 31 seconds, so you have to be careful here. We're going to grab the values from 31 seconds and then the values from 9 seconds, and we're going to compare those as the ends of my interval. So for runner A, the ending distance was 287, and the beginning distance was 120, and the ending time was 31, and the beginning time was 9, and you would subtract those values. So let's see here, that would be 167 over 22. And then for runner B, the ending distance was 287, beginning distance was 120, and the same time interval. And what you're noticing is we're actually comparing the same rate of change, 167 over 22. So on that interval, they do have the same average rate of change. So even though if you look at the previous part B, over the interval from 9 to 20 seconds, runner B did run faster, but I'll leave the calculation and see for you to show. But obviously, runner A must have had the faster rate of change to catch up to runner B. By the end here, they had the same rate of change over that interval. Okay, number 3 says to find the average rate of change for each of the following intervals using the graphs. So to find a rate of change is a little easier when you have a graph because you can actually just count the distance traveled for the y coordinate and the x coordinate. So for number 3 here, or part A, the interval -1 to 1, if you don't recall what an interval is telling you on a graph is, that is basically saying from x equals 1 to x equals 1. Right, so that's this point here at x equals -1 to 1. And we're just going to calculate the change in y over the change in x. So if you figure out how far of a distance you have to travel up, that's called your delta y, your change in y. And the distance over to get to the next point horizontally is called your delta x. So as you can see, the average rate of change, right, would be delta y over delta x, which is up 3 and over 2. And just to give a little clarity to what average rate of change might mean graphically, is this should feel a lot like slope. It's not quite slope, but you could interpret it as, well, what if there was a line that did go between those 2 points? Right, like that. What if there was a line traveling between those 2 points? The slope of that line would be 3 over 2. So the distance, or sorry, the rate of change you find between 2 points would be the slope of a line that travels between those 2 points. So you're not technically finding slope, but you kind of are. Okay, the next one gives us an interval from 0 to 3. So they've highlighted the points here. So we're going to go from this point here to this point here. So the delta y would be, we're traveling up a distance called delta y, and we're traveling horizontally over a distance called delta x. So our delta y over our delta x would be 7 over 3. And just a remark about the signs, the reason why everything has been positive so far is because on the y-axis, when you travel up, that's positive, and when you travel right, that's positive on the x-axis. So in this example, we're going to be going from on the interval from 1 to 2, so that means we're going to start from this point and we're going to travel down to this point. So here we're going to encounter going down instead of going up to get to the next point. So now our delta y is this distance, and our delta x is this distance here. Now, since delta y has us traveling downward to get to the next point, then you have to incorporate a negative sign, because when you travel downward on the y-axis, that is a negative value. So it would be -2 as our delta y, and positive 1 as our delta x, so that'd be negative 2. Okay, so now I give you another graph, and I have some intervals to look at. So we'll start with D. We want to look at the interval from -5 to 2. All right, so from -5, that's our x value. That's this point here, right? That point has an x value of -5, and we're going to go to 2, which is right there. So what you'll notice is, to get from this point to this point, and we calculate delta y over delta x, here's the issue between those 2 points. Your delta y is 0 because you don't have to travel vertically at all. So our delta y is 0, and our delta x is 7, right? You have to travel 7 units to the right. But 0 divided by 7 is 0, so our rate of change is 0, right? There is no change in y versus change in x. Okay, the next one. We're going to go from -3 to 0. So at -3, the y value is up here, right? That's our -3 on the x-axis. And we're going to go to 0, which is down here. So to get from that point to that point, we need to calculate what's called our delta y over delta x. So let's see here. You have to go down. Let's count it. I'll use my laser pointer here. So you have to go 1, 2, 3, 4, 5, 6 is my delta y. And then 1, 2, 3 is my delta x. So because we traveled down to calculate this, delta y over delta x would be -6 over 3, which is -2. And I'll leave f for you to try. Lastly, we're going to use given functions to find rates of change on the intervals given here. So we have 3 functions, f of x, g of x, and h of x, and we're going to find a rate of change on every interval. So the easiest way to think about this is kind of like what we saw previously. If you have a table, you could just grab the values from the table, right? So what we can do is I can just make a quick x and f of x table. And we just want to find what's going on over the interval. So our interval should begin at -4, and it'll end at -1. And we can calculate what's going on with f of x. So for f of x, we're going to be calculating f of -4. So x squared minus 9. So that'd be -4. All right, so -4 squared is 16, and minus 9 is 7. And then we're going to calculate x squared minus 9 again. X squared minus 9, but now it's -1. -1 squared is 1, minus 9 is -8. So now we know the y value at the end of the interval and the y value at the beginning of the interval, and now we can calculate rate of change, which is our delta y over delta x. I'll just use that notation again. So to calculate delta y, that's the difference of your y. So the end of our interval is -8, and the beginning of our interval is 7. And you would subtract those over the end of our interval is -1 x value, and the beginning is -4 x value. Subtract those. And of course, if you need help subtracting using Desmos, I highly recommend using a calculator like Desmos. So -8 minus 7 is -15. And -1 minus a -4 is actually +4. So -1 plus 4 is 3. So that means the rate of change is -5. Try the next one. G of x on the interval -2 to 0. So I'll kind of copy what I did before. I'll have an x and g of x table. And that'll take me from the beginning of my interval to the end of my interval. So the beginning of my interval is -2x, and x is 0. And then we're going to plug that into the function -2 absolute value of x plus 1 for both of them. X plus 1. And we're going to plug in -2 and 0. Okay, well, in the absolute value there, we can use a little bit of help. I'm going to go ahead and call a little help from Desmos here. Okay, so what I want to do is I want to plug -2 into this expression, right? So I can actually just type it out. So -2, absolute value is right above the ABC. -2 plus 1. And that's -2. Okay. And then the next expression in the table is -2 absolute value 0 plus 1. And we get -2 again. So those are my y values in my interval, and -2 and 0 are the x values in my interval. So let's calculate the rate of change for this. So delta y over delta x would be -2 and -2, 0 and -2. We subtract these values. Now that would be -2 plus 2, which is 0, over 0 minus a -2, or minus a -2, which is plus 2. And 0 divided by 2 is 0. And lastly, we have h of x on the interval 0 to 3 over 2. So I'm just going to go ahead and make a little shorter work of this one. I'm going to go ahead and just write delta y over delta x. So I know my delta x is 3 over 2 minus 0. But now I just have to use Desmos to help me. So I'm going to plug 0 and 3 over 2 into 6 sine of pi x minus 3. All right, so there's my function, 6 sine of pi x plus 3. So 6 sine of pi, and then we're going to start with, we'll do 0, so pi times 0, and then plus 3. And then the other evaluation is 6 sine of pi times 3 over 2, and then plus 3. So those are my ends of the interval on the y-axis, right? So my end of the interval has a y value of -3, and the beginning of the interval has a value of 3. So that would be -3 minus 3, right? So that would be -6 over 3 halves. And if you're scared of doing -6 divided by 3 halves, we can ask Desmos to help us with that. That would be -6 over. Now, since we're doing another fraction, we're going to hit the division symbol again, and it gives you another fraction to work with. So 3 on top, and then 2 on the bottom of that one. And the answer is -4. So the rate of change over that interval for that function is -4. Well, I hope that helps with rate of change. Thanks for watching.